The linkage is subjected to a force of 6 kilonewtons. Determine the angle theta for equilibrium. The spring is unstretched at 60. Neglect the mass of the links. So we have a 6 pounds, and we're going to call that distance x1. So we have 6x1. We have a force in, and we'll call that force of the spring, and that's x2. So minus Fs x2 equals 0. So x1, this distance here, is going to be the same as here. So that's going to be 0.9 cosine theta minus the force of the spring, which now we'll call Ks, is going to be 1.8 cosine theta equals 0. Now we'll take the derivative, and this is 5.4. The derivative of cosine is negative sine d theta minus 1.8 Ks sine theta d theta. The d thetas cancel out, and the sines cancel out, and we have 5.4 equals 1.8 Ks. K is 20, so dividing 5.4 by 1.8 and then gives us 3 equals 20s, so s equals 0.15. Now the spring is unstretched at theta equals 60. So let's draw a little picture of that. So if theta equals 60, what is this distance that is x2? So that's going to be x2 is equal to 2 times 0.9, that length there, 0.9, cosine 60, and that equals 0.9. So if this distance here is 0.9, and then it stretches an additional 0.15, the new length will be 1.05. So cosine of theta, where it finally comes to equilibrium, is going to be 1.05 divided by 2, well, that divided by 0.9. And that makes theta equals 54.3 degrees.